We start off often by giving you an overview of our product portfolio and sometimes go into our company history. I'm not going to go through the full company history today, but I do want to let you know that a little bit about the basics of our battery and our company. So SimpliPhi Power started in 2010 as optimized energy storage. And this whole time we've been based on LFP battery chemistry, which is lithium ferrophosphate, lithium iron phosphate batteries, which are safe, non-toxic batteries. You're using iron instead of cobalt for the cathode, and that provides a safer battery in terms of just disposal, recycling, but also in terms of use. So we really have no risk of unmitigated thermal runaway during fires. And other batteries can't claim that same thing. Cobalt-based batteries are notably dangerous for fire hazards. We are a UL certified battery producer. We have UN Department of Transportation certifications as well. And these certifications allow us to airship some of our batteries. We're proven. We've had over a decade of experience. We've been deployed in more than 45 countries. We've got over 250 megawatt hours installed worldwide. We're tested and validated by the US Army and Marine Corps. So we have a history with them in our early days, 2011, of providing solutions for the military and going through stringent testing with them. We offer simple solutions. So one of the ideas behind our batteries is that they're very simple to install. The Phi battery is a great drop-in lead acid replacement. And our batteries are there to provide customers with the opportunity to control their energy needs and be able to provide backup power. There are many different reasons people want battery backup, right? So it's time of use, maybe save some money through peak shaving, demand charge management, etc. We have released a new ESS system, which is shown on the screen below, or on the bottom of the screen there. We also, as many people don't seem to know, have a whole high voltage solutions division. So our high voltage and projects team is available. And if you're interested in doing a large project and getting some input on it, you could check with us and we'll connect you to the high voltage division. So we have our ESS. We also have battery cabinets and access cabinets, as you're going to find out today. Those are particularly relevant for installs in harsh environments. Here's another overview kind of showing you different products that we have. We have mobile products. We again, like I said, have these access cabinets and our whole high voltage product line as well, which is shown in the top right, the racks there with the stack controller at the top. So let's get into the meat of today's talk. Today's training is on temperature considerations. And if you have questions throughout this presentation, please use the Q&A feature. So you should be able to pop questions into the Q&A, and Daniel's here with me and can answer some of those questions. Daniel, are you here with me? Can you confirm?
Yes. Hi. Thank you, Nathan. I am here, and I'm happy to answer any questions. Go ahead and pop in the Q&A chat.
Thank you very much. So the operating range for our batteries, for lithium batteries, is from -4 Fahrenheit, that's -20 degrees Celsius, all the way up to, ooh, sorry, it looks like it's supposed to say 60 Celsius on the far right there, up to 140 Fahrenheit, which is 60 Celsius. So -4 degrees Fahrenheit all the way up to 140 degrees Fahrenheit, or -20 Celsius all the way up to 60 degrees Celsius. The operating temperature is the temperature at which the battery is capable of discharging. You'll see that the charging temperature is slightly restricted. Charging can actually occur with our smart batteries, our communications-enabled batteries, below 0, but it is at a decreased rate to protect the battery. And we'll get into why that is the case, but this is true with all lithium batteries. They should not be charged in very low temperatures. So storage temperature. We get a lot of questions coming into technical support about what temperature the batteries can be stored at, and if they're at particularly cold temperatures, how long they can be stored in those cold temperatures. We get questions coming in from Alaska, etc. People want to have these stored over the winter. And so the rules of thumb are here at the top. The recommendations are you can store for 6 months between -10 Celsius and 25 Celsius with no damage to the battery. And for 3 months, if you're even colder, at that -20 Celsius to -45 degrees Celsius range. Prolonged storage at ultra low temperatures can eventually damage the batteries, but generally the problems with batteries end up occurring when they are charged at below freezing temperatures. So knowing these storage temperatures is important. You'll have a copy of these slides after this presentation is finished. I'll be emailing them to all registrants. So let's start off talking about our Phi battery. The Phi 3.8 kilowatt hour battery is shown here on the screen. This is our typical lead acid replacement battery. This product line does feature a BMS, but the BMS does not have communications, and there's no temperature control for this battery. So it's important that you plan accordingly and design your system so that to protect the battery from charging and discharging below the temperatures, below the temperature specifications that were outlined above. The range of this battery, as I said, I highlighted it to you in the beginning, -4 Fahrenheit all the way up to 140 Fahrenheit for discharge. Some inverters allow for temperature control, and so you'll want to be careful to include that with this type of battery, but I'll also give you some additional options for external equipment that you could employ. The SimpliPhi battery is a bit different. It has a more advanced temperature control built into the BMS system. The temperature ranges, for both charging and discharging can be controlled by the BMS unit. And there are really two layers of protection here: the internal BMS and then the communications, which can communicate to charging and discharging equipment such as inverters or hybrid inverters or charge controllers. It can communicate how quickly the battery wants to be charged, discharged, or not at all. It can shut it off as well based on temperature. A similar control system is built into the SimpliPhi battery. This is a 4.98 kilowatt hour wall mountable battery. It's outdoor rated. And this battery has the same type of BMS feature, the same type of communications that the SimpliPhi battery has. So installing in cold temperatures, installing in cold environments, it's important to consider where the batteries are kept, right? And the internal temperature of the batteries can often vary from ambient temperature. So batteries, when they're being used, produce some amount of heat, right? And that heat is being produced inside the cells of the battery and can keep the battery slightly elevated in temperature compared to the environment. But it is important when you're in cold environments to try to keep the batteries warm. And if it's as simple as installing in an outbuilding, like is shown in the picture, that can help prevent the large changes in temperature which occur outside overnight, and keep a more stable overall temperature. If the batteries are charged repeatedly in cold temperature environments and exceeding the range that was shown, it can damage the batteries and reduce the overall cycle life. So to get the most out of your batteries and the longest duration of use, you'll want to make sure that you're installing them in appropriate environments, keeping them warm if possible, and also, as we're going to talk about later, avoiding over temperature. So as I mentioned earlier, the SimpliPhi battery is capable of using the communications to reduce the charging rate. And the charge rate that is communicated depends on the temperature. So if we get below -20 degrees Celsius, the SimpliPhi BMS will communicate to the charging equipment that it doesn't want to receive any charge. So the charge rate goes to 0 below -20 degrees Celsius. From -20 Celsius to -10 Celsius, it only charges at 1 amp. So it's more of a trickle charge in that range, and that's to prevent problems inside the battery. And then from -10 Celsius to 0 degrees Celsius, it'll charge at 3 amps. From 0 to 7 Celsius, the BMS communicates that it wants to be charged at 7 amps, and etc. 15 amps when you're from 7 to 15, and 15 to 25, it's 30 amps. Now, in order to take advantage of the communications-enabled battery, you need to have an inverter that properly interprets and applies this charging range. And our inverter, the SimpliPhi 6 kilowatt inverter, is one inverter that will do this, and Solarc inverters are other inverters that pair well with our communicating batteries. We are looking to expand this and have been in communications with a couple of other companies to enable the communications with their equipment. But there are other methods that you can use to maintain stable temperatures for your batteries. And one of those is simply just to use insulation, right? So the batteries do produce some amount of heat, and having the batteries within an enclosure can help to retain that heat. Additionally, you can use things such as insulation to line the walls of cabinets, line the walls of an enclosure, and even set the batteries on top. So setting the batteries on top of a piece of insulation will prevent conduction of heat out of the battery. And lining the walls, of course, will keep the enclosure at an elevated temperature by preventing heat from escaping from the enclosure itself. We have additional solutions that you can use for cold environments, and one of those is to have these heating pads. So this is active temperature control. The previous slide using insulation was on passive temperature control. Active temperature control, these batteries are special order, but the BMS can use temperature to control heating pads. And these heating pads, the batteries can be set on these heating pads, and these heating pads can heat the case of the battery. This is a nice feature, but do keep in mind that it does use some of the battery's energy to control temperature. There are external third-party devices that can be used as well. And so what I'm showing on the screen here is a Victron BMV 712 smart battery monitor with the optional temperature sensor. This smart battery monitor will allow for temperature compensation for batteries because the voltage of batteries varies slightly with temperature. So it gives you a more accurate state of charge. But it also, this BMV 712 can communicate the battery temperature to the charge controller. And in the case of Victron, this will allow for low temperature shutoff on the charging cycle. Hot temperatures can also damage batteries. And the temperature range for charging batteries is up to 120 Fahrenheit or 50 degrees Celsius. So if you're installing in a hot environment or an environment that's prone to lots of sunshine, even installing our bigger 4.98 battery in direct sunlight, right, you'll want to pay attention to overheating of the batteries as well. Similar to cold weather cooling systems, a thermostat can be utilized as well as insulation to mitigate temperature, so you can have active cooling equipment. And it's important to note that the internal battery temperature may be different from ambient temperature. So there are a couple of factors at play there. There's the thermal mass of the battery, meaning that the battery itself takes some amount of time to change temperature because it has some thermal inertia, so it will change more slowly than the environment, and then air especially. But the battery is also producing heat, as we mentioned. Another important consideration for where you install your batteries and how you install your batteries is humidity. And humid environments can damage electrical equipment, right? Atmospheric moisture by itself doesn't really pose a threat to these batteries. The batteries are sealed batteries. However, there are some issues that can arise. And one of those is that if the battery is at a very low temperature, you can have condensation, right? And another one is if there's salt in the air. So one problem that we've had we've noted before is in extreme marine environments, right? That salty air can promote corrosion, especially on the cases of the battery. So it's important to keep those in mind and to try to protect the batteries. We've had cases where rain has directly has rained directly on our batteries, and that obviously can cause problems. You can get moisture buildup under your battery, so it's a good idea to elevate the battery case. The battery case is a steel powder-coated case. It's a good idea to elevate it off of a rack if there is moisture on that rack. And it's important to keep the batteries out of salty air. Humidity in air can hold salt, and that can be corrosive.
And Nathan, I did want to, Daniel here, I did want to bring up one point is that we do and have been making the metal powder-coated battery enclosures, but we also have the option by special order to do an ABS plastic case for the 3.8s, and some of our smaller batteries come in the ABS plastic case. So if you have a marine application or someplace you know you're going to be seeing that, let us know and we can get you those ABS cases for you.
That's a great point, Daniel. And one of the advantages of that ABS battery is it is approved for air transport with UN 3812. Altitude. So altitude, our batteries are actually made on cylindrical cells, and these cylindrical cells are hermetically sealed, and so they can go to high altitude, low pressure, though it can cause problems for prismatic and particularly for pouch cells, does not cause a problem for cylindrical cells. And so our batteries, which are based on cylindrical cell manufacture, have no problem going to high altitudes. However, it's important to note that typically low temperatures are associated with high altitude installations or high altitude locations. And so it's important to pay attention to the temperature at high altitude, just because you can have a low temperature environment. Vibration can also pose a hazard to batteries. Excessive vibration can damage components. However, our batteries have really gone through a lot of testing. We did testing, as I mentioned earlier, for the military. Department of Defense has used our batteries and carted them throughout Afghanistan, and their design proved tolerant of vibration. A common application, which might include some vibration for batteries, is installations in mobile trailers, such as mobile homes or RVs, as they're often called. And vans are another common instance in which you might have some vibrations. And there are some things that you can do to reduce vibrations on your battery. One of them would just be to install those batteries on top of a vibration dampening pad or a mat. And other things involve isolating these batteries from locations in which severe bumps can occur, right, depending on where you install those batteries. So making sure to pay attention to those considerations will help to extend your battery life. We've gone through a lot of testing. So SimpliPhi Power has an extensive testing program, and we've gone through UL testing. And some of the types of tests that we've gone through are UL 9540, UL 9540A, UL 1973, and 1642, and I'll be talking a little bit about those. We've spent a lot of time at our headquarters, which is shown there, improving the batteries and really trying to optimize batteries for extreme environments and making sure that we have a long life for our customers. UN 38.3 is a test that is associated with transport of batteries, and it includes taking batteries to elevated altitudes. And these batteries, to simulate high altitude, batteries are stored at low pressure for prolonged periods of time and cycled. Thermal cycling is done by rapidly changing the temperature between 72 degrees Celsius and -40 degrees Celsius. So dropping the temperature and then bringing it back up in rapid succession. This type of thing would occur if you were transporting your batteries on a flight right? As you go to very high altitude, the temperature drops very quickly. And so if you're wanting to transport your battery by air, you would want to make sure that that this rapid thermal cycling does not damage the battery. Vibration can also occur, right? Turbulence or even transport in trucks. So to simulate this, 36 hours of intense vibration is used by putting the batteries on a vibrating platform and then testing them afterwards. And then shock, the batteries experience 18 different impacts, simulating repeated drops or crashes. And in order to pass this test, no leakage, no venting, no disassembly, no rupture, no fire can occur. And an open circuit voltage test on each battery directly after testing not less than 90% of its voltage prior to the procedure. So this cycling, this thermal vibration, et cetera, cannot damage the battery and cannot cause elevated reduction in the voltage in order to pass. And so our batteries have gone through this 38.3 test. There's an external short circuit test. And this test simulates basically the battery being short circuited. So the battery is heated to 57 degrees Celsius for 6 hours. Then terminals actually short circuit the battery. So we're going to short circuit across the terminals of the battery until a maximum temperature is reached and then cool it down. It must not exceed 170 degrees Celsius and it must not catch fire to pass the test. And then there's an overcharge, so twice the maximum charge current. So we're going to charge the battery much faster than it's rated for, and 1.2 times the max charge voltage. So go 20% above the max charge voltage, and the battery must not catch on fire. So as I noted, we have this certification for our batteries, and that's available on our website. UL certifications for batteries come in a different variety. So there's a cell level battery certification, which is UL 1642. And this is conducted by a third-party underwriter's lab. And this certification involves certifying the cells. So in order to pass this test and receive this UL certification, the batteries go through a number of different, the battery cells go through a number of different tests that are similar to what was described with the UN certification. There's shock, vibration, drop testing, heating of the cells, temperature cycling of the cells, low pressure, which is an altitude simulation as before, short circuiting cells, abnormal charging of the cells, forced discharge, crush, impact, etc. And if they successfully pass this test, they get a UL 1642 certification on the cell level. All of our batteries are made with cells that have this certification. There's a second level test, which is a module level test. And this is typically what people refer to as the battery, right? The battery module is the entire battery composed of many cells wired together and inclusive of a battery management system. So the BMS is kind of the brain of the battery that's in there as well. And UL 1973 refers to that, the entire module, the cells, as well as the BMS and the complete enclosure. And there are tests here that simulate over voltage and over current conditions, and both with and without the BMS safety features intact. So they could actually short out the battery without the BMS unit there to protect it and take it through a different series of tests to make sure that the battery, again, is not going to catch on fire and it's going to remain safe. So it receives a wide range of abuse and thermal runaway, trying to get the battery to go into thermal runaway, and I'll talk a little bit more about that, but that's UL 1973 on our battery level, and all of our batteries have gone through this testing. Then there's a whole system level test. That's UL 9540, and this relates to system level safety, which would include charging equipment, an inverter, etc. And so UL 9540 is done with our inverter. We're in the process of completing that and should be soon. We've done this for our access cabinets. Our access cabinets are our battery cabinets that include the inverter inside. And our bus configurations or our battery cabinets have been tested with different inverters as well. There's another test that's used to inform the 9540 certification. It's called the 9540A test, and we've completed this with all of our equipment. The 9540A is a test, it's not a certification, but what it does is informs safety considerations around spacing, around the use of different equipment together. And there's a series of fire tests. And Daniel could talk a little bit about this, but what is actually done with this test is to intentionally cause battery fires. So they will take apart a battery, wrap individual cells to try to force that battery to go into a thermal runaway, get that battery hot enough that the cell off gases, right? And then observe what happens to the equipment around it. Daniel, do you want to say anything about that test?
Sure. Yeah. Thank you, Nathan. So again, just kind of think about how 9540A helps inform what safety mitigation strategies may need to be employed that will then be called out in your 9540, which is the certification that Nathan had previously mentioned. 9540, the certification really is just helping to vet that these pieces of equipment that are being combined together into a larger system don't introduce additional risks or unforeseen risks when you bring pieces together. And then whereas the 9540A, again, as Nathan said, it's not a pass-fail test. Really what it is an observation of what happens when we force some of our battery cells, battery modules into a thermal runaway event with propagation. What we found is that with ours, we didn't have that unlimited, unmitigated thermal runaway, right? We saw that the cells did go into a thermal runaway with propagation, but then they kind of just put themselves out, and we didn't need to employ many of these other various safety mitigation strategies that other mainly cobalt-based chemistries do have to employ.
Thank you, Daniel. And I think it's important to note that, you know, with these safety and certifications, our batteries also are one of the only batteries to be approved for use in New York in skyscrapers. I think Tesla and maybe one other company are currently approved by the Fire Department of New York, and that has to do with the safety of SimpliPhi batteries. Right, LFP battery chemistry, as Daniel mentioned, is a much safer type of battery chemistry for backup, and this test kind of notes that and highlights that. So when a competitor uses a cobalt-based battery, such as NMC, and goes through a similar test like this, it's a much more exciting test because the fire does not self-extinguish as easily as it does with ours. Briggs & Stratton has a whole set of courses that you can do online, and I wanted to speak a little bit about the Briggs & Stratton Power Academy and let you know that you can sign up for taking courses within Briggs & Stratton, including battery courses. You can do them at your own pace there. So it's an online learning platform, and the URL to this learning platform is there. As I mentioned, you're going to get a copy of all these slides. Another way to access this platform is to use the link that's there, the QR code. If you scan that with your phone, it will take you to the Power Academy sign up page. One other method would be to just text the word learn to 33988, and that will send you a link. I promise we won't spam your phone. That'll just send you a link to go directly to this Power Academy. So the beauty of this Power Academy is you're going to have lots of content there around generators, home standby units, ESS systems like ours, the batteries that we've been talking about, and you can access those trainings through the Power Academy by signing up. So once you've signed up for the Power Academy, if you want to enroll in battery-based courses, you could search for the word SimpliPhi, and then there is a whole series of different trainings and courses that are on there around SimpliPhi and our batteries. Wanted to tell you something else as well. We have an elite installer qualification program. It's called the IQ program, the Elite IQ program. And if you're not already signed up as part of the Elite IQ program, you can be, and now is a good time. So we've got installers signed up around the country, around the world, really. Not showing the whole map here, but we have installers in Australia and Africa and in Europe as well. And there are several reasons to join this program. One of them is you get $25 back, right, cash back per battery that's installed. When you join this program, we send you a free swag pack. You get additional technical support, direct technical support with senior level technical support on the phone and have that relationship with us. Another reason to consider joining the program right now is Briggs & Stratton is offering a $500 sign-up bonus for joining the IQ program as an elite installer. And that will involve just a 1-hour course and a 20 to 30 minute quiz. And when you sign up after completing your first install, once you register that installation's warranty, you'll get a $500 cash back bonus. And you're also eligible for $25 back per battery installed as well. So this promotion is running until the end of the month. And so the link is there. Again, you'll get a copy of these slides. You can also get a direct link to the sign up for this installer program by using this QR code that's on the screen. And I want to thank you. I appreciate your time. If you're here for NABCEP credits, please send an email to training@SimpliPhi and we'll be happy to respond. Daniel, are there any questions in the Q&A that have gone unanswered?
No questions in the Q&A. If you do have any questions, now's the time, and why somebody may be typing it in. I do want to do a little plug for the upcoming NABCEP conference. It's going to be in St. Louis, just outside St. Louis, coming up at the end of this month. And one of the talks I'll be doing is building and explaining more of that UL 9540A testing and how safety is crucial for what we do here at SimpliPhi Power, and we like to make that safety visible. So we're one of the few people that actually publishes our 9540A report. You can find that on our website. So I'll be going more into depth in that. And then Nathan, you will be talking about battery management systems,
yes,
and why they matter, and understand the different battery management system functions. And it was interesting to note in the UL 1973 that we tested the battery with and without the battery management system. So still no questions, Nathan. But
thank you, Daniel. I appreciate you plugging that, and do come see us at NABCEP. We'll be offering those courses there and look forward to meeting with you. So if you're here for NABCEP credits, please send an email to training@simpliphipower.com. Thank you for your time today. Hope you have a great day.
Thank you, Nathan. Thank you, everyone.